Well, good morning everyone. So in this video I'm going to be disassembling a battery from a Kia Niro plug-in hybrid. So this arrived today and it's actually much lighter than I was expecting. I'm actually able to lift the side of this pallet up with one hand, so it's not as ridiculously heavy as I thought it would be. So this is the battery out of the rear of the car. It's the sort of hybrid battery, the smaller one, and I reckon it's about 7 kilowatt hours. But in the Kia Niro, the battery is actually in two parts. There's actually another battery that goes with this, which I don't have, which is a smaller one, which is 1.56 kilowatt hours, I believe. So this is the bigger of the two. And I'm going to be disassembling this today, so let's get started. So let's cut this away. See what we're dealing with. There we go. So the weird thing is that there's actually no capacity markings on this at all. Looking at all the stickers, there doesn't seem to be any indication of how much there actually is. Usually on lithium-ion batteries, I think they're supposed to state the capacity. So that's a little unusual. So we're just having a little look around here. This video is sort of for insurance purposes as well. But this one came from I think it was a 2020 car, so it's still reasonably fresh. I think there's meant to be a high voltage fuse in there, which is missing, but I'm not needing that anyway. And here's probably that's probably for CAN bus, other control stuff as well. As you can see, it's a reasonably thick object, and this air pipe here, that's an air cooled battery and probably air heated as well. And this battery normally sits under the floor of the boot in the back. Okay, this is actually from a 2021 car, so it's very fresh indeed. So what I'm going to do is I need to open it up and measure the cell voltages, because like say all the cells are sitting at like 2 volts or whatever, then that's grounds for rejection of the pack and send it back to the seller, because when you pull lithium ion down that low, it's probably damaged, and it's not really a good idea to charge it after that, because it discharging them really deeply, it can compromise them sometimes. So I'm not sure what I'm going to be using this for at present. Possibly it could be used for an electric motorcycle project, I reckon. But also, if you look at the size of it, it's about the size of a fuel tank out of a normal car. So it would be great for just like a little experimental electric car project where it'd only be for little runs about the town. You'd probably get maybe 30 miles of range out the thing. So hugely impractical, but fun for an experiment. So I've got my 10mm socket here, and I'm going to take all these bolts out, and I'm just going to bore you with the whole thing. I don't think I'm going to cut too much, just to try and show you the whole disassembly process. Oh, my drill is not liking that. Yep, we're not getting much luck there, so I think I need to get the spanner out. Right, okay. Wow, that is not really wanting to move. And there we go. That was very tight for some reason. Yeah, there's something weird going on there. because I accidentally turned it the wrong way. Right, here we go. Right, that might just come off now. Oh, what a nightmare. Just watch where you're putting your hands as well. Don't touch any sort of connectors or bus bars just in case they're live, because there's enough voltage inside these things to kill you instantly. So just a quick little overview of what we're dealing with here. So I reckon this is the main battery management unit here, which actually communicates with the cell monitoring modules, which are, I think they're located down there, those little silver things in there. And I will be disassembling these in separate videos. I'll be disassembling this just to let you see all what's inside, and we'll go from there. But I think we've exposed enough to do a voltage test to see what sort of a voltage this thing is sitting at. Well, there's actually not too much point doing this just now, because I don't actually know how many cells in series we have. So whatever voltage reading I end up with, well, I'm not going to be able to really know. We're just taking all these little nuts and bolts out just now. Okay, so with all the bolts that I can see out of the top, they're actually there's just 4 underneath, as far as I can see, that need to be taken out, and then I think this top will just lift off. Okay, so there's a few more bolts just around the side that I had to take out, but it's worth noting that there's not a lot to this battery. I can lift it, so it's not ridiculously heavy. Definitely not anywhere near the 150 kilograms they quoted on the delivery. So now we just need to unplug some of these cables so we could get this top part off. So I'm just going to do this sort of electro boom style, not really. I'm just hoping that none of these small connectors have like 200 volts going through them. I don't think they will. Famous last words. Some of them are quite awkward to remove, so I'll just skip that. Right, okay. This part's going to be fun, because all the heads of the bolts are still in there, so I'm going to have to try and lift this piece off. I've just forgotten something, this will need to come off too. Still one, you always forget one. Right, I think I should pull the lift off now. Okay. Still got lots of things stuck to it probably. Yeah, we've got something in here with sort of buried blind connector clips, which I can't really get into, so I'll need to take care of those. Right, here we go. What a nightmare. Right, so we've got two sets here, modules. I'll try and give a good overview of those. Right, So you see a heat sink in there, so clearly air cooled, as I said, and these all need to be taken off obviously. So I just need to try and find some points I can measure voltage. So the small 1.5 kilowatt hour, which is a smaller, thinner, sort of long unit, it uses the same modules as are in this, and I'm sure each module has 16 cells in it. So looking at the electric scooter over there, I think it would like 16 cells, although I don't know if my motor controller would handle that. But anyway, these are the monitoring modules in here, so I reckon they'll just have a balance plug plugged into them from each set of cells, so I could just maybe take a measurement from there. One thing I will mention though is the construction of this battery. Now it's all plastic, so say this was to get involved in a really nasty crash and burst into flames, well, I'm pretty sure those flames are just going to go right into the passenger compartment very fast. There's nothing to this really, and when my friend showed me it, I'm sure it was just a sort of composite material boot liner thing that just goes over the top of this. So well, it does have the metal, I suppose, but I don't really know how I feel about that. All these lithium polymer batteries behind me with not that much protection. At least in the BMW i3, they're all underneath the car and they've got a lot separating them from you, so it gives you time to escape. But then again, this is behind you, so it's maybe they know what they're doing. So we're at the stage now where we may be coming into contact with potentially very dangerous voltages, so I'm going to put on some rubber gloves and start carefully opening these connections so I can try and figure out how to extract these modules. Right, okay, so they do sort of move around freely in here after we've taken the top off. So it looks like what I'm going to need to do now is got an exposed sort of high voltage connection there, which leads to the end of this fuse. So I'm going to have to very carefully remove that. Yeah, oh well, I'll just use the drill. It's insulated enough anyway. Get those out of the way. Okay, so I definitely don't think that each of these modules are 16 cells, because I did some maths, and if they were, that would be 96 cells, so that cannot be the case. The entire battery in the BMW i3 has got 96 cells in it, so I think it's maybe a different number. So all I can really do is just take it out and figure out how many cells we're dealing with, and then we'll see if this is a damaged pack or not. So I've been at this for quite a while. I'm still undoing various clips and connectors and everything. Absolutely shocking the way this thing's put together. Obviously didn't intend the thing to be serviced. Don't know why they didn't just weld the whole thing shut in an aluminium case and be done with it. So yeah, still struggling with these battery management wires. They're just secured in with these clips, which you actually have to cut off, because you can't really get into the back of them very effectively. So I'm just trying to cut all them off to free everything. Here's some massive current sensor here, probably a Hall effect current sensor, I'd imagine. For sense the main pack current. But judging by how thin these cables are, this pack probably would only be given out about, well, looking at the specifications of the smaller pack, which is just like, it's just quite a long unit. I'm sure it said it could give out 30 kilowatts, so this is maybe about the same. I think this is, I'm getting the feeling this is the same, it's identical to the smaller pack, but it's just arranged differently. These are actually beside each other. I don't know, I might buy a smaller pack just to try and compare them, but because I'm just trying to get all my money out the bank just now, because inflation is just going to start going nuts, and I'm just trying to get all my money into various assets. I think what I might actually end up doing is just selling the modules out this battery if they're actually good, because see these on an electric bike, these would be absolutely amazing. They're not these cheap Chinese cells that you normally get. These are automotive quality cells. They're designed to last, and they're lithium polymer, so get these on a motorcycle, small motorcycle, or like large long range electric bike. Oops, they'll be just absolutely brilliant. In theory anyway. I'm just trying to remove this thing, it's really doing my head in. Okay, so this is where we're up to now. It's still not freed, by the way, still attached with all this crap here. So now I'm going to have to figure out how to take these out. Why can't I just use Molex connections or just something, you know, normal? I don't know. So we're going to have a little fight with these and try and take them out without destroying this. So we'll have to be careful, because I'm sure, well, looking at this one here, that's kind of going to be connected to the cell, so that's actually the balance lead, so we need to just be careful that we don't short anything out. It looks like each monitoring unit is doing 2 modules, so yeah, we just need to be careful. Like, what have we got here? Just so many wires, it's unbelievable. You would have thought it would just be like a few for power and CAN bus, but it's like it's just got so many. It's insane. Okay, after much struggle, that's much simpler than I thought. So you just push in the tab like that and then pull. There we go. That's simple enough. Still a lot of hassle though. This one seems simpler. This one here, so we don't have to muck about with that. Just push in and pull. Right, look at the amount of pins in that, the amount of wires coming out of there. So those are the connections to the cells themselves, and that's all the communication, power, and goodness knows what else. I'm almost certain that's going to be a temperature sensor. See, it's just unbelievable how overly complex things are. Like, compared to my battery management system, this is ridiculously complicated, but I appreciate that it kind of has to be, it needs to be compact. My battery management system obviously is just never going to work for these types of systems where the cells themselves are very compact, because I'm designing my own battery management system, but it's nothing like this, it's much simpler. So anyway, now we're just going to continue taking these out. So there we go. Once you figure it out, it's simple enough, but yeah, what a lot of messing about that was. Right. So there we go. I think we could, well, I'm just trying to figure out how these are even wired, because I want to try and figure out what the voltage per cell is here. So it's just weird how they've wired this. It's I don't really know what they were playing at, but okay. So we'll pull this one out and we'll get access to some cells here. So let's see how many wires we've got. We've got 1, 2, 3, 4, 5. So 5 wires usually means 4 cells, but knowing this, it's probably been wired in a different way. It's not like your typical wiring of an RC LiPo pack. We've got one extra wire, so what I'm going to do is just, there's no dangerous voltages here as far as I know. Right, so I'm just trying to get my leads in to try and get a voltage off this. So I'll just stick them in here, see what we're sitting at per cell. No, I'm just not getting any sense out of that at all. Just can't even get the test lead in. Right, there we go. 3.72. Not fantastic, but not absolutely terrible either. So 3.72, and yeah, I reckon the whole pack is sitting at roughly 3.72 per cell. Which is okay. That's fine. That's totally acceptable. The Outlander plug-in hybrid pack that I got was fully charged. Leaving these sitting fully charged all the time is bad for them, but 3.72, that, I mean, that's fine. Like 3.8, that's the ideal storage voltage, but yeah, that's okay. So we're just going to take the rest of these off and try and free this up, and then I'll show you these modules. I don't think it's a good idea to start disassembling the modules themselves. Chances are the cells are ultrasonically welded together, and just it's probably going to be more hassle than it's worth. I think we're dealing with 6 cells per module. That's, if we've got 1, 2, 3, 4, 5 wires, probably the ground wires and another connector or something, so probably 6 cells per module. And so 2 of them will make a 12 cell pack, and just looking at my electric scooter, that'll fit on the scooter. Okay, so we've just to get these off now, after we've finally got this module removed. So yeah, those are in really tightly, and there are bolts at the end of the thing as well, because of these being lithium polymer. As they do get older, they do puff out a bit, so they have to be clamped. So I'm not sure how I'm going to do that for the scooter, but I've never clamped them, but it does help if you do. Ideally they should be clamped, and there we go, there's the module there. Not waterproof in any way, it doesn't need to be because it's inside the car. So we'll do a little disassembly on that and see what we find inside. So we've got sub written on them, so that might be the name of a company who makes them, as well as some sort of weird logo, which I've never seen before. But still, I'd imagine that they're high enough quality. Right, so next I'd like to get these bolts out of the end and take this end plate off and see what we're dealing with. I'm sure that's just a protective cover, not the actual cell itself. But before we try and remove this particular module, I'll need to try and disconnect it in here. I'll need to get that little clip off there so I can get the bolt out. I might actually be able to disassemble these modules quite a bit and see what's going on inside. Because I mean, it would be nice to have the option to be able to take the individual cells out and then connect them up in parallel, and then have you and like configure your own packs for whatever application you like. Right, so that's that out. Probably going to have to take the whole thing out, but I'll just get this out of the way. Oh, there we go. Of course it's still got something stuck to it. Yeah, still got a balance wire on here. So I just need to try and fight with that a bit to get that off. Yeah, that's a interesting design, that. There's a better way. Just pull it off. Well, that did work with the last one that I did, but this one is just not having it. There we go. Well, that's how you get that off. I think you need a special tool to push in the front of the connector, and I just don't have that. Okay, so now I'm going to try and take this little module apart and see what we can see. As usual, when I need my tools, they just vacate the entire premises, so I'm stuck with what I've got. So we'll just unclip this here. Totally not the right tool for the job, but what can you do if your tools disappear every time you need them? Not much I can do about that. Okay, so straight away we can see that we've got some sort of welding going on. I don't know what that's made out of, whether it can be soldered to. I reckon one's going to be nickel, one's going to be aluminium. So I think soldering to that is just not going to be an option. That's the tabs coming off one side of the cell there. So let's turn this around and see if I could get anything more sensible out the other side. Right, okay. Yeah, another far from ideal tool. So we've got something strange going on down there. I'm not entirely sure how on earth they're connecting those up. That probably goes down the entire length of the cell. Yep, yes it does. Here we go. So we've got a big bus bar. No, that's not a bus bar. Oh, those are the balancing wires inside there. So let's see. I don't know if we'll be able to get this top piece off. Judging by what we're seeing here, I think that's glued. So that's all glued together. It did come off there. Because if I could figure out what material that is, it might be possible to solder to it. But that being said, if one of the tabs are aluminium, you're pretty much screwed. There's no way you're soldering to aluminium. Well, that's that coming off anyway. Let's just see what we're dealing with. It's worth maybe sacrificing one of them, right? Giant power tool battery maybe. So these cells are manufactured by SK Innovation, a company I've never heard of before. So we've got what looks like a nickel tab there, and this one's going to, I can safely say that's an aluminium tab, that one there. But the saving grace here is that you can actually cut this. If you were to cut that down the middle, you could actually potentially solder to this material here. So that's what I did when I disassembled RC LiPo packs. I'd actually cut down where the tabs were joined, just after the weld, and I would actually retain that material which I could solder to. So I reckon we could try and take this apart, but I'm not really sure. It's already in a useful configuration for me. It's already got a number of cells I need. That's what I'm actually trying to establish, how many cells are actually in this thing. So we've got 5 wires. So I think there's probably going to be 6 cells. 1, 2, maybe 3, 4, 5, 6. Well, okay, after much mucking about, more than it should have been, I've established that this is a 4-cell module. So we've got 14.88 volts here. So that's consistent with a 4-cell module, and we've got 1, 2, 3, 4, 5 wires. So each of these modules are 4 cells. So for my electric bike, I would need 4, 8, 12. I need 3 of these. So those are not going to fit on the electric scooter because they're too large. So yeah, looking at that, it's just really not happening, unfortunately. Yeah, here was me thinking that each of those modules had like 16 cells in it, but yes, I was very wrong. So actually, I think for my next experiment, what I'm going to do is I'm just going to do a charge and discharge test on these. So to do that, I'm just going to put a normal sort of balance connector on there, which would fit my charger, and then I'm just going to connect it up to my charger, charge them to 4.1 per cell, and then discharge them to say 3.5. I will decide on the voltages later, but just to try and get a rough idea of what capacity these are going to give, and this way that I discharge them, because I never charge these batteries fully, because I want them to last long. I'll only ever charge these to 4.08 per cell, and that does me fine, even though I sacrifice a bit of range. I just noticed something quite interesting here on the side of the module. There's this little switch. So what happens is, if the battery swells up too much, I'll show you, it actually triggers that switch like that, so that it'll probably send out some sort of error, meaning that the battery needs to be replaced. It's just to let you know that something's badly wrong. So it does have a few, you've not got much, I think, right? You've got about 4 millimeters for that to move before it actually triggers. So yeah, they've really taken safety into account here. So yeah, if you're going to take these apart, it's probably better to take off all the bus bars before you then take the ends off. But looking at these cells, looking at this type of battery with it being lithium polymer, it is a cheapest way. This whole battery costs £980. So the price per kilowatt hour is pretty decent for what you're getting. So you've got lithium polymer batteries there, so you can use these on high powered electric bikes, motorcycles, possibly a drone if you strip them down enough. So the possibilities are pretty endless for these batteries. But I'd love to use these in an electric car project, but obviously there's just not enough here. I reckon I want to do a Volkswagen Bora at some point, but for that I would probably need 6 Kia Niro packs to be able to make that dream come true. And the thing is, with lithium polymer, these pouch cells, I'm pretty sure they can actually discharge, if they're clamped properly, they can discharge more power than cylindrical cells can. At least in my experience, but don't quote me on that, please, because I could be wrong. I think there's a reason why they use pouch cells a lot in high powered applications, because they are simply more powerful and they're quite light as well. So I think I'm going to leave this video here. So that's all the modules out, and that's the carcass with all the wiring in it. I will do more videos regarding the pinouts of the battery management modules, well, as best I can anyway, some disassembly of the battery management modules. But I will finish with a word of advice, as it's to do with the way these are designed. I would not advise taking the individual cells out of these casings. unless you're going to mount them properly. Because the thing is with, like, I reckon the reason that LiPo batteries for like RC aircraft and things fail is because you're just putting a strap around the cells themselves. So like if you just put a, like obviously cells are folded up at the sides, but if you put a strap around that, you're stressing it from the sides, and then what happens is it creates an internal short circuit. Not a really low resistance one, but it accelerates self-discharge, and sometimes it could just cause the cell to fail entirely and just puff up. As you can see, look at how these are mounted. They're kept separate from each other. There's actually separators between them, and they're in a nice frame, and that's to keep them well protected. That's the thing with these pouch cells. They need to be mounted properly as well. So I don't think I'm going to take these out of here, as I don't currently have an idea for mounting them safely. I'll just keep them in these safe casings, and the applications I'm going to be using them for, I might just use some of these modules for my electric bike projects and sell the rest, just to try and build up some money to use for even bigger battery projects, most likely for the electric car project I'm going to do at some point, but that's a long way off, because for the electric car project I need to develop a charging solution. I've then got to develop the inverter to power the motor, DC converters. It's very, very involved, and the battery management systems you get to buy for these DIY projects are ridiculously expensive, so that's why I'm trying to develop my own. But there are people working on reverse engineering various modules from these. So there's someone working on reverse engineering the Kia Niro modules. I had a look at that, but they've not got balancing working yet. So hopefully in the future we'll have that. We'll have cell balancing. We'll have software libraries that we could just download and use the battery management systems from the cars in our own projects. So I reckon what I'll do is I'll just cut these connectors off and just leave them so that they could be attached to the cell monitoring modules, because the way this works is this goes to the next battery. So if each management module, this would be plugged in, is actually dealing with 8 cells. So that's how it looks. So I'll make more videos about that anyway. I think this video has been long enough, so thanks for watching.